Hello. In this section, we're going to look at some of the various string methods that you can use to help manipulate the data that might be coming into your program. And we have two short examples to go over that are very similar to this week's lab. If you take these two examples that I'm going to quickly go over here and meld them together, you basically have this week's lab. The third example is a little bit more involved, and it will also help us review some of our graphical user interface techniques. So you'll find these files in Angel. This first one I'm looking at is called Strings1. I believe that's the same title you'll find in the Angel environment. So what we're doing here basically is we are going to create some random sentences. Now we know we can create random sentences by defining our parts of speech and then putting a sentence together to reflect those parts of speech. In other words, we could have a sentence that was just consisted of an article, a noun, and a verb. The boy ran, or the boy talked, for instance. But we can also add an extra parts of speech, a preposition, and another noun in that sentence to make it even a little bit longer if we created a sentence with an article, a noun, a verb, a preposition, maybe another article, and another noun. For instance, it might sound like this: a boy talked to a girl. Would make a sentence made of random from the data you see in front of you here in my arrays. So what we have here are just arrays of parts of speech that we will then randomly pick from to create our sentences. And we'll have our sentence structure predefined. So what we'll do is we'll create an array of sentences. In this example, we'll have 20 sentences created. We'll have a string, an array made up of strings that we'll call sentence, and then once we create our original sentences, we'll create another array that will be our replaced sentences. Now you notice that these arrays are not parallel. Some have more data than others, and we could continue to add data to any of these without needing to change any other type of material in the program. For instance, we could say man, or we could add woman to that as well. Whoops. We're not saying these are parallel arrays. They are just arrays of articles that parts of speech that we will access. Now the nice thing about this is when we process this data and get our random numbers, it's all done on the length of our arrays, and since the length of arrays is automatically updated as an array grows, particularly as we add these initializer lists, we will always know how many things we have to process. So what we'll do here is first of all just generate some. We're going to create a sentence made up, as I mentioned, an article, a noun, a verb, a preposition, an article, and another noun. We'll make up 20 of those. So what we'll do is we'll generate random integers for 20 sentences. Sentence length is 20. Remember, all arrays keep track of their own information, how long they are, in this variable called length. So we've said to make your sentence an array of 20, so this will loop 20 times once for each sentence. We'll get a different article number, and now again we're generating an integer between 0 and the article array's length. The article array's length is 4. So we'll generate a 0 between an article number between 0 and 3 because it's always one smaller than the array's length. And we'll do that for each of our parts of speech. And then we simply build the sentence through concatenation. We access the article array identified by the article 1 integer we generated. We access the noun array based on the noun 1 integer, and so forth throughout that sentence. We want to print both the original string and the revised sentence. If we print the original string here without any changes, it's going to look, we'll see that there in a second. And then we'll put a change in here. We will capitalize our first letter. We'll talk about that in just a second. Notice also that I concatenated a period on the end of the sentence, but we might not exactly like how that's going to look, and that will be one thing you'll want to solve in this week's lab. But let's run it and see what we're going to get. just a little slow. There we go. So here's my console window down below. I can grab it. And we see this is my original sentence, the woman saying to one boy. Notice my period's a little bit too far away. I said that's a problem you'll solve for this week's lab. And then my slightly changed sentence with my capital, the woman saying to one boy. Now we get that capital letter in here by using one of these string functions, and that's what this section's all about. And we're going to use substring. Substring is an overloaded method. In other words, based on the parameters we send it, that will determine what substring will do for us. And to capitalize the first sentence, the first letter of this sentence, we take our sentence string that we built up here, right there. We go to the substring starting at position 0 and going for one position. In other words, we just want one item. We send that to uppercase. Then we concatenate that with sentence, again, subscripted at J. That's the one we're working with this time through. And then we send it, the substring, just a single parameter, just the number 1. And when you send substring a single number like this, it says, okay, start at that location in the string and take the rest of the string and add it to whatever we're concatenating. Now, that's how we got this second line printed. Now the third thing we do here is a simple replace all command. And again, these are pre-built methods that Java has for you to work with strings really are powerful. All we have to do is say that sentence J, we want to take that sentence, and every time we will find a lowercase o, replace it in this case with 5 dashes. And you can see that's what we have done here. The woman sang to one boy, our original sentence. Capitalize the woman sang to one boy. And then down here we notice that we are missing our O's replaced with those dashes. One thing you do want to notice it did not replace the capital O because it is case sensitive. So although it will replace all lowercase O's, it does not replace an uppercase. One woman sang at the girl was the original. We changed it to one woman sang at the girl with an uppercase O. Therefore, that uppercase O was not changed to the 5 dashes in the subsequent replace all. So just a short example, but powerful. Not long at all, but pretty powerful. Let's look at our second example here, our strings 2. This is what we call tokenizing a sentence. And again, you're going to take this idea and meld it into the sentences you're creating for this week's lab. For this example, though, what I've done is I've started with 2 sentences. A boy sang to a girl, and a girl ran for a boy's home. And what we're going to do is take those 2 sentences and break them into tokens based on the letter lowercase o. And so to do that, again, these are powerful commands. We tell it which sentence we want to work with, sentence in our array J spot, which in this case will just be 2 because I only have 2 sentences. And we want to split at the O. And this will build an array of string items that we are calling tokens. In other words, every time it finds an O, it's going to split and put your sentence in a token spot. It doesn't know ahead of time how big this tokens array is going to be. It builds it dynamically as we go. This next sentence will just tell us how many splits it found, the token length, because the token length, remember, length keeps track of an array's size, so token length will tell us how many splits there were. Next, we'll print out each token by stepping through, again using a for loop, working through the tokens up through the tokens length. We're going to print the tokens array. Remember, this tokens array was totally built by the Java machine by you using this split command and putting its results in a string array. Let's see what that does. So this was remember my first sentence was the boy sang to a girl. Notice it split. The number of splits is 3. If it went to the lowercase b in boy, it did not include our tokenizer, our delimiter here. It just ignores that or gets rid of it. Our second token then starts after that delimiter And that's where we get Y sang T. There's that other L on 2, and then a girl. This next one, a girl ran 4. There's my split at the O. 4 boys. There's my split at the O. YSH, split at the O. ME. Notice how it almost makes this tokenizing here really turns this into what really made sense a second ago into kind of gibberish unless you really understand where the splits were and what was being done with that. Just kind of interesting to note. So that's a pretty simple example, but all of these string things are easy to understand, and there's tons of them you can use and work with, and we're just presenting and using a couple in this week's lab. So those are the first 2 examples. Our last one here is tokenize and translate a simple message system. Oh, hold on, let me just go back here just a second to these examples. Okay, I just had to make sure I had shown you the import of the random there. I couldn't remember. Because in this example, notice we do have quite a few imports. Because once again, we're building a graphical user interface, so we have all these JFrame, JPanel, J components, our label, our button, our text field, some listeners. We're going to mess around with our color and our font. Let's run this one right off the bat so we'll see what it looks like before we go very far. So this is going to put a GUI right in the middle of your screen. With this, enter your message using a simple message system. Please enter your message using the short message service SMS. Then press the button for translation. Well, short message service we use all the time when we're texting. You might put in LOL, and then I click the process, and it translates that to be laughing out loud. I might put that, whoops, I keep forgetting I got to hit click the process, and I will get as far as I know, because these are our standard simple message or short message service messages. The way this comes about is that we will work with parallel arrays. We have what we call our SMS snippets, which are the codes themselves, and then the translations, and they can say these are 2 parallel arrays. Each entry corresponds with its other entry in the other array. So as far as I know, goes with our first entry. AFK goes with away from keyboard. LOL, I used that one already. It goes with laugh out loud, and so they have to be kept laughing out loud. They have to be kept maintained in parallel for this translation system to work. Well, this kind of follows our standard way of building a GUI. In this case, we have our main in our actual file we build the GUI from. So to do that, remember what we've done in some of our previous examples, and there are a couple of basic ways to do this, but what we've done in our previous examples is in our main we just call a method called create and show GUI. That basically builds our JFrame. Hopefully you'll recall that a JFrame is simply the frame that holds our picture. There it is, I couldn't find it. Remember I've said before that a frame holds our panel, and our panel is like a canvas. So what we're going to do is call the tokenize translate SMS complete, is what the COMP stands for. It's going to create a new instance of that we'll call demo. We'll create a frame. We'll set our content of our frame equal to the content pane that we create from our demo. And then these other standard items, set the layout to null so we can use absolute positioning. Set the default close operation so we don't get hung up when we X out of our GUI. Set the size of our frame. Set the relative location to null. Remember, by placing this after the set size, we're going to put that frame right in the middle. And finally, we'll set the frame visible. So remember, all of our content is handled in the create content pane. And since we have an action listener, as we'll see in a second, we'll need one other pair of methods. So tokenize translate SMS complete implements action listener. And remember, that means we'll have to come through here and create a copy of our action performed paragraph, because the action performed method is abstracting the action listener, and we have to implement that. Our create content pane, we will create our panel called Total GUI, and this is what we'll put all our items on. And we've seen this as we build other GUIs, and we just had a big GUI exercise, so this should all be pretty familiar to you. You're going to use a font, make it a little fancier, our layout a little bit fancier instead of using the defaults. We'll have a label that will ask us to enter our message. Our direction label, we did this once before, where we have a label where we split it into different parts by using HTML code, and by using this HTML tag here, that allows the compiler to also recognize these BR or break commands, and each one of those break commands will give me another blank line. If I want 2 blank lines in a row, I would use 2 break commands, or tags as we call them in HTML. And then at the end of this long line, I end my HTML tag. And remember, put all of that in quotes. You can do other things with that too, but that's a simple way to get a multi-line label. We set our location of our label, our message text field. That's where we'll actually enter our message that we want to have translated. Our translation label is where we'll place the translation once our message is translated, and that's simply our button to get everything rolling once we got our message in there to translate. And so again, we're doing our standard stuff, just adding working with some of the components and their attributes, changing some fonts, getting our location set so we have a nice organized GUI. Remember, the last thing we do, we add some listeners. Now in this example, only the button action listener has been implemented. I leave it as an exercise to you to implement the message text field action listener if you could. And it pretty much parallels what we do with the my button add action listener. You just have to perform some more coding in your action performed paragraph. So our button is activated, so we'll come down here. This is our action performed. Remember, all programs that implement action listener must include an action performed method. Alright, so now the first thing we do, we want to find out who fired our action, and if the source is my button, and in this case that's the only thing we have going on, but this is standard technique how we usually do it. Find out who created the event and then take some action based on that. So what we'll do is we will now use some of those techniques we saw in our earlier example. Is we will first of all read our message text field by getting the text and putting it in a string called sentence. We're going to tokenize this sentence at the spaces. So let me run an example again so you can get a better idea what we're talking about here. We start here and I put in, oh my, OMG, it is raining. Not funny. LOL. Now notice when this translates it only translates when it recognizes the code. Oh my gosh. Then if it's not in code, it puts our text unchanged. It is raining. It should say not funny. Laughing out loud. LOL. So that's how this works. It's going to split these into tokens and then see if any of the tokens it comes across match into my array that holds my codes. So that's the first thing we do, is find our number of splits, and that number of splits prints when you run it in the window here, and the number of splits in that last example was 7. So what we'll do now is we have this sentence array that we can step through one at a time. Remember, this array is our tokens array. Right here is the one we're going to work with and step through, that was built from our sentence. So we'll step through this, going for each element in the token. We will now check to see if the current token can be found inside the coded snippets. If it is, then we take that coded snippet and find its JDEX and use that JDEX value to access in parallel the translations array and add that to our translation string that we built. And we build this translation string one item at a time. We start with translation, we concatenate to it a space, and then if we found a match, we concatenate the translation in here next, and then we add a break just for readability. That break could be left out if we wanted it. But if we don't find that, if we step through all the SMS snippets and we don't find our current token that we're looking at, then it will be down here and say, if not found, then the translation will be whatever the token is. In other words, the token will add that token onto the translation. And so we'll build it one item at a time. At the end, then, we'll end our translation with our closing HTML tag so that we can get this multi-line label on our translation label itself, so we can see it in multi-lines. So running this example one final time, we might put LOL, LAL, just so you can see what's going to happen here. LOL, LAL, OMG, it is rainy. HH. Click the process. Laughing out loud, it found that match. Notice LAL was the next token, but it didn't find a match on that. OM, another token, it didn't find a match on that, so it just printed it as it was. And then it comes down with it is rainy. Here's my next token. Now, on this it is rainy, it adds these one token at a time. It is rainy, not all in a row. And then it matches the HH to our ha-ha. So that's just a little bit more involved example of what you can do with strings. And hopefully that will help inform you as you work on this week's lab. Good luck, and I hope this has helped you out a little bit.